Hi, everyone. Welcome, Azure Cosmos DB Live TV. Welcome to this week's episode, episode number 43. And I've got with us here this week, Sarah Dutkiewicz. Did I get it right?
You did.
Oh, my God. Nice. Welcome to the show. It's great to have you.
It's good to be here.
So, Sarah, you're is it an Azure MVP or data
No,
platform?
I'm a developer technologies. So not Azure, not data platform.
Wow. Okay. So that's great. It's great to have you on the show. I've been wanting to bring on more community folks onto the show. I've been looking to see what can I do to expand kind of what we do here on the show. I think to date, for almost the last year, actually, since we started this podcast, we primarily had people from the PM team and some developers as well on the team, just to talk about new features and stuff. And over the time, we've had some partners on and a few other community folks, but I really wanted to bring on kind of actual practitioners, like people who really do use the product, and just have them come on and talk about, I guess, your experience, your background, how you've used Cosmos in the past, and then, in a good MVP sense, like share kind of what you know and what you've learned over time doing that. Because I'll be quite honest, it's Cosmos has got a bit of a learning curve when you use it, and also if you're someone at least like me, like I've got decades of using developer or using relational databases as a background for most of my career. Not so much using something like a distributed NoSQL database. So I know it can be a struggle, I guess, for some developers. I mean, I guess in some sense, the less you know, maybe the easier it would be, because it seems like some of the people that struggle the most are those that are most fluent and most ingrained with how to design and build for relational databases. So I thought when you mentioned kind of the topics you wanted to talk about, I thought that'd be great to have you come on and just share some knowledge about this and share, well, just anything I guess that you wanted to tell us about. So how's that for a setup? Did I do a good job?
I think you set me up here really well.
Yeah.
So,
okay.
And the reason why I wanted to do data modeling is I've been 20 plus years in the relational world. So dealing with SQL 6.5, SQL 7.0, SQL 2000, the old stuff is where I was doing a lot of database administration stuff. So relational for me that's my bread and butter. Writing reports, building SSRS servers, things like that. But
Ooh, like Crystal reports? Are you a big Crystal reports user?
I did Crystal reports. I did Fox Pro and had to do Fox Pro reports.
Data window. Did I get it right? Was it data window? Is that the thing? Or was that Power Builder?
Right. That sounds like one of those. It's been so long.
Data window that you had to make one of those things. I did Fox Pro back in the 90s as well. And Power Builder. I think they had a similar construct as well.
They were very much similar.
Data window thing. Anyway, I won't.
Oh God, yeah.
I won't bore you folks with how old I am. But anyway, so yes.
So yeah, I had such an extensive career with relational, and then modernizing and going into things like SQL, Azure SQL, and doing Power BI, looking at Azure Synapse a little bit. So I've been looking at some of the modern stuff, but that's all relational. My background, I do both data side and development side, hence why I'm on the developer technology side of things. But I ended up working for a client that had Azure Cosmos DB. They were using the SQL API to store documents. And me with my relational mindset, not really knowing what was going in there, I was like, oh, why is this? What is this? How does this even work? And so because of that, a few years ago, I was just like, okay, let's dig into this deeper and see. Well, coming with the relational mindset and the organization, I was just like, how do I translate that into a non-relational or a NoSQL database? And that's when my head just kind of exploded. There's a lot of frustration trying to get into it and understanding it. I had to get past the relationships and the relational. I had to kind of get past the description because you see the term non-relational, but there's still relationships in some of the data that we look at. And so today I wanted to show data modeling, specifically wanted to show the document store using the SQL API. and then showing graph databases using the Gremlin API. And that's just because they've got two different use cases. And so I've got a demo here that I'm going to show.
I think Greg, showing graph is particularly interesting in the context of, I come from a relational background. What is this database? Why? How do I use it? Like, I think people kind of understand at a low level, like there's like relationships kind of within this graph, and that you can kind of key off of that. But there's some interesting differences, obviously, and how they're implemented within there. So anyway, I won't interrupt you. Go ahead. That's a lovely looking pizza.
So I have some controversial data here because, well, pineapple on pizza can be a hot topic for some.
Yeah.
But I like using food for examples because people can relate to it. And so even though my ERD here, so my entity relationship diagram, this is your relational store. You got customers, you got orders, you got your items, and your customers are going to order items. So I want to keep it fairly simple. Yeah, there could be other fields here, but for simplicity's sake, this is what we're working with. So what I did here is I was like, okay, how do we work with this in a SQL relationship? That makes sense for those of us coming from old school, just let's stick with relational data. But how is our data being used? Is this something where maybe we have somebody, like maybe I'm a customer and I want to pull up my order history? Do I really need to have my order spread out across multiple tables? Once I place that order, those details aren't going to change. Maybe we just store all those details together in a document. And so let's take a look at what that looks like and why we would do that. So this is going to be the question you'll hear as we look at the various examples is, how are you using this data? And I have a checklist. So number one is, how is it being used? That's always going to be at the top. Who's going to be consuming this data? What are they consuming it for? Why are they consuming it? Then what fields are queried together? Because if data is getting queried together over and over again, then it makes sense to group it. How often does that data change? And is it read heavy or write heavy? That all comes into play. All right, so let's talk about a document database first, and starting with how we go from relational to document. So schema list is something that we have to get used to. It's one of those that with relational data, we have our schema. We have our things need to be organized a certain way. But when it comes to document data and storing it, so we're talking JSON, it's going to be a little bit different. When we think about relational data, we think about normalization, not repeating our data, keeping it well organized. But when it comes to document stores, that's not necessarily the case. A little repetition is okay because, again, how is your data getting used? So what we're going to take a look at is we'll talk about this customers and orders and items, and we're going to look at what does that denormalization look like. Now, the example I will show is going to get into embedding, but then we'll talk about what's referencing data and why you would do that. Partition considerations is another thing too. So partitioning allows us to group our data, have it stored together based off of a partition key. So we'll have to mention that as well. Just as we do the demo, I'll talk through that. But there are also a couple of links here. So the Azure Cosmos DB documentation I found to be super helpful when it came to getting into the mindset away from relational into these other things. So the modeling data in Azure Cosmos DB, this link is for the SQL API, which is what the document store demo here is going to show. Then the other link I have is for Azure Cosmos DB Essentials Season 2. If you don't know about the Azure Cosmos DB Essentials, check them out on YouTube. But the schema design strategy specifically will help when it comes to data modeling. Okay, so denormalizing data. Rather than having our tables of customer and then order ID, order date, order details, we're going to use order history as an example because that data, once you place an order, that order is probably not going to be changing or change very little. So how do you know whether to denormalize your data or to put data like this together, embedding your data? Well, there are a couple cases to keep in mind. You want to see, are these relationships, do they belong? Order details belong to orders. It's pretty set there. One to few relationships, I'm going to put asterisks on today's demo because it's a very small data set. So I can argue in this case to do this with a one to few. Infrequent changes, our order history shouldn't be changing much, so this makes sense. Query together, typically if I'm looking at my order history, my details are going to be there. And then data has bounds, meaning that you really have a limit as to how much you're going to have. I'm not going to have an infinite number of order details, and so I'm okay with embedding it in this case. But the other approach you could have for modeling for a document store is actually using normalizing and referencing, where you use the IDs for your objects. This is common for one-to-many relationships, many-to-many relationships, data that might have to change often, or data that has no bounds. So think of like you have a collection of something and it needs to be represented, but you don't know, like there's no set limit as to how many. So maybe, for example, like retail and a wish list. And you could be like, I want all these different things. That could be something that's limitless, in which case then looking at normalizing referencing might make more sense. The things to note with this, there's no foreign keys, there's no constraints. So if you're referencing things by ID, that's something that you need to manage on your own. And then going the normalize approach, there's no joins in the relational SQL sense, so you're going to have multiple queries and multiple round trips. And this is more seen for write-heavy loads. Now, I have to go back. There is something I saw in the documentation that I still can't stress enough for everybody else, which is if your data is relational, if your use cases are purely relational, don't try to move your data to Azure Cosmos DB just to say that you've moved it there. If you have these use cases, that makes sense. But I've seen so many people like, well, I want to try the databases and I'm just going to drop it in. And SQL is SQL. And I'm like, oh no, SQL is not SQL. It's a different kind of SQL.
I wonder this too sometimes. I mean, I'd love it for everybody to use Cosmos, just so because they pay me money every week or 2 weeks to be around here. So I want to help them that sense. But there are times it doesn't make sense for every single app or workload that you're working on. I mean, you can put highly relational data in a document database like Cosmos, and yes, you can build things around it to help maintain referential integrity and implement your constraints or whatever. But just use a database for what it's meant for, right? So
exactly,
Cosmos. Cosmos has some clearly communicated use cases, if you will, and so just use the right tool, I guess, right?
Exactly.
Yeah.
Exactly. And that's how
when you say requires more round trips, do you mean in fetching the data? Or because you could use a query, unless it's in a different container, I guess, if that's what you mean.
They're going to be in different containers. So with a traditional SQL query, the relational stuff, you have joining between tables. Well, if you're going to break your tables into like containers, then now you have to do the manual queries, round trips, and passing the ID around. It's a lot more work.
Right, yeah. So if you can't denormalize all your data into a single document, then it may end up in a separate container if it doesn't share that partition key, in which case you're going to have to query separately for it anyway, versus data that you do denormalize into a single document. You can fetch that with a point read, no query necessary. Or if it's a bunch of documents that share that same partition key, you could get it with a query. Like, I guess if you had a container of orders, I don't know, let's say maybe they're partitioned by order ID or customer ID, you could grab like order header and order details all in the same query if they all use the same partition key. But if they're separate, I don't know why you would, but just I guess that's the thing for people to keep in mind. If it could share the same partition key, you can potentially put it in the same container and grab it with a single query. But if not, then like you say there, it's a separate query.
Yep. And
Yeah.
that's why I have
Okay.
to that's why I have to stress it's no joins in the relational SQL sense, because that was something that also broke my mind, was looking at the SQL examples for the SQL API in Azure Cosmos DB, and then knowing my joins from a relational data set. And I'm like, wait, that join is not doing what I think it's doing. And so that's why I have to stress that the joins that you're going to see, and I don't do a lot of demos with joins, but I do have a demo that shows it. It's not going to be like joining across tables. It's going to be intra-document. And when I show you the example, you'll be able to see that a little bit better. All right. So how are we using this data? Let's take a look at our demo in the document store. And we're using Azure Cosmos DB SQL API. Now, while I'm waiting for that to flip over, there's also the API for MongoDB. It's another way of accessing documents, but I'm not showing that here because SQL API just made more sense for what I was showing. Now, I am currently, you see it? Yeah, it did flip over.
Yep.
So I am using, this is the full screen version of Azure Cosmos DB, but let me unfull screen it so you can see. No tricks up my sleeve. This is the document store. This is within the Azure Chrome. There's this button over here that says open full screen. When you click on that, it gives you a link that'll take you to the full screen. You open it in another browser tab. And I'm just going to press F11 to full screen it.
Yep.
So no tricks up my sleeve. I have this order history and I have a bunch of items, and I'm going to go ahead now. If I were to select items, just so you can see what it looks like, this is essentially the Data Explorer UI. You'll see I'm in the SQL API. There's an ID. There's my partition key. In this case is customer name. And so if I go ahead and I click on one of these, you can see what my documents look like. So I can see there's the customer name, the order ID, the order date, a bunch of details. Just try not to scroll too fast. And then, of course, the internals as well. All right. So what I want to show you with this part is being able to use SQL to query these documents, and that this SQL is not necessarily the SQL you're used to from a relational world. Now, the starting query that you'll see in Data Explorer is it's usually select star from C. Now, Mark, that C, does that stand for container? Does that stand for collection? Why C? You happen to know?
It stands for nothing. I don't know why we use. I think it was collection. It's just an alias, right? And
Right.
frankly, even if you got rid of that, select star from, I believe that still works. Even if you took the C off of there, I believe it'll still work.
Well, and that's, I have most of my other queries here, we go into aliases that make sense. And that's just because I see C everywhere and I'm like, it doesn't mean anything for what we need.
Yeah, it doesn't make any difference because queries are always executed within the scope of a container. So it's just a way to alias
The container.
Stuff. Yeah, right.
All right, so now you can select the fields. This is going through, so these objects are JSON. So you can see I want just the customer name, the order date, the order details. I don't have at this point then all of the other, like the underscores that you would see before. Only bringing back the fields I need, much like we do in the relational sense. Now, some of the things I wanted to show with this is that you can use your where. And so far, this is looking like SQL, other than coming back with some JSON and querying JSON. And I'm not pressing F5 because I am in the browser, in case any of you are wondering why I keep clicking the button. F5 will refresh my screen and then all my query stuff goes away. But you can see here, I have 4 results. Now in the Azure Chrome side of it, you have the list of results and you can select them. But in here, not so much. But you can see as we scroll through that there are results there. Now this other thing to note is your query stats. So just making sure with your queries, the request charge. And this gives you a few more stats as well. Query stats also does appear on the Azure Data Explorer side outside of the full screen. So similar to what we see in regular SQL. Now this is where this join comes into play. And the reason why I bring the join in, so my orders, I have this order details section, and my orders details section has a collection of JavaScript objects. Notice their order line IDs, item names, quantities, unit prices. If I want to be able to filter on it, the easiest way for me to bring this in is to do a join intra document. So join, this is the alias in, and then what's the property that I'm trying to join on. In this case, it's my order details collection. So this allows me then to say, find where the item name is either pineapple pizza or cheese pizza. Now you can also do things like aggregates. So how many people or how many orders are there for pineapple pizza? You can do the count where you can see what are those orders, things like that. We can find out how many by using like your comparison operators. Those are there. So I mean, the SQL should look fairly similar. These are people who've ordered more than 2 pieces of a particular pizza type. Let me see what those orders are. So if we want those details, you can use distinct and so on and so forth. Now, if you're wondering how I remember the syntax for it, it's similar enough to SQL that I could type it live if I had to, but rest assured, I don't have to know the SQL off the top of my head because Azure Cosmos DB has these things called cheat sheets. Do you happen to have that link, Mark?
I do. I can put that up for you.
I love those cheat sheets.
You do?
I do, because it makes
We need
it
to
easy
update
for me.
those things. We need to update them. We've added much more system functions and other stuff in there since we released those. But I'm glad to hear you like them. And given the fact that you like them, and we're talking about them now and sharing them, I will have to redouble my efforts to make sure that we go and get those updated with the latest and greatest stuff in there. But yeah, thanks for pointing those out. I think they do make it a little easier. Like you said, it's very SQL-like until it's not.
Mm-hmm.
So,
Mm-hmm.
like
and having those cheat
normal,
sheets, I was like, how does this go again? Oh, that's how it is.
like ANSI SQL or Transact SQL, not really built for dealing with embedded arrays, whereas Cosmos SQL, yes.
Exactly.
Given what we work on. So yeah, cool.
Yeah. So being able to query the document store like that works. But notice that we chose the embedded details because it makes more sense for what we're dealing with. So how is this data getting used? I want to see my order history. I want to say, you know what, show me, I want to see my order date. And I want to see my order details from orders. Whoops. From orders. Oh. Where that customer name is equal to me. So what does that look like? Notice it's just one query. It gives me everything. I don't have to worry about joining the tables and following that out. So the queries for an order history in a document store, much simpler than having to trace all your joins. All right. That's document store. What I wanted to show you with that, with the modeling and being able to embed if you need. Now let's talk about graph data. And this is where I mentioned how like that non-relational asterisk, there's still relationships in there. Graph databases help to be able to analyze those relationships. So this particular example, I've got a few people who I've referred to my pizza store, and they've placed orders for pizza as well as I have. And so you can see various arrows things going on here. We'll take a look at this in a little more detail, but just so you can see that I am connected to at least 3 different types of pizza. And Mark and Matt also are connected to cheese pizza. Carrie isn't connected to anything here, but we'll talk about that here when we look at the demo. We'll see what those all come to. We will also take a look to see who bought pineapple pizza. So graph databases, they have a couple common use cases like fraud detection and recommendation engines, managing IT networks, software dependency graphs, things like that are just some of the many examples for graph databases. The demo I want to do here is the start of a recommendation engine. So we'll take a look at how do we find the people who bought pineapple pizza and what else they also bought. We'll come back to this query, but just so you're aware, this is Gremlin syntax. Again, those cheat sheets, they actually have one for the Gremlin syntax as well. So rest assured, trying to figure all this out, you've got some help. Okay, so this is using the Gremlin API, using the Gremlin syntax. The 2 main concepts to know about are relationships and things. In our case, we have customers, and we have items, and we have different relationships for those. So we have customers who refer to other customers. That's one of the relationships. And then we have customers who bought things. So that's another relationship. Together, the relationships and the things, they're known as a graph. And again, I mentioned their common uses like recommendation engines, fraud detection, things like that. Now, a little secret. That SQL API is still at the core of Azure Cosmos DB. So I was using one of the tools out there. So if you use Visual Studio Code, my friend Savran Hassan, he created a plugin. It's the Cosmos DB SQL Studio, and it uses the SQL API to make calls. So I was able to query the database. This is what a vertex looks like under the covers in the JSON. Now, why would I do this? To show you that it's JSON under the covers, but also just because you can query it with the SQL API doesn't mean you should.
Yeah. You definitely shouldn't update it using SQL API either.
Oh God, no, no. But just so you can see that this is getting stored as JSON. Now, when it comes to graph database considerations, there are a few things you need to keep in mind. You want to know your relationships. You want to know your vertexes, your things and your edges. You also need to know the directions. So I bought a pizza that's going from me to the pizza. So it's coming out of me going into pizza. Vertices, the nodes, they're stored with their out edges. So anything that I bought is going to get stored with my node. Anything that I referred is going to be stored with my node. So my node has a lot of edges. And that's just because that's how it happened to work for this example. Be warned that there's a in and that is cross-partition. So that could be a bit expensive, but if it's used frequently, you can consider adding edges in both directions. And rest assured, there's an easy way to tell how your query is going to be executed. You can look at the execution profile. So we'll look at that in the demo. Graphing at scale, just so that you're aware. My demos are small so that we can work with them, but Azure Cosmos DB is built to scale. It does horizontal scaling. You'll see this partition key, just like we had a partition key on the document side of things. It's used for balancing the load of data. If you're using Gremlin drivers 3x or higher, or if you're working in the Azure portal, it's required to have a partition key. You try to create this data in the portal, for example, and that partition key, that red asterisk, will yell at you that it needs there. Gremlin drivers 2x and below, supposedly you don't need the partition key, but this demo, I'm actually staying in the Azure portal, so you'll see the partition key. Vertices are stored on there based on the partition key. Edges, again, are stored with their sources. And there's a link for that. And then to talk about 2 different graph strategies, and we have a link for that as well from the Azure Cosmos DB Gremlin API documentation. So vertex-based properties versus property-embedded vertices. What we're talking about there is taking that relational mindset and thinking of, okay, what all do I need to include in a graph? And then how much data do I include and where do I put it? It all goes down to what relationships do you really need to evaluate? For example, with my pizzas, I'm looking at the fact who's buying them, and I'm also looking at the people that I referred to the platform. Those are the only things I'm looking at. However, let's say that I had multiple people with the same name in here. So for example, I have two friends named Steve Smith. One is a .NET guy, one is a SQL guy. They both are here in this area with me. So my mind melts when I'm like, both Steve Smiths are here at the same time. But in order to differentiate them, they have IDs. You can store that ID as a property on that vertex to therefore clarify, okay, which Steve Smith am I working with? Now, why would you do that? Maybe you have that Steve Smith and his profile information in a relational database. Then you can use that ID as a reference key. So just something to think about is that just because they have properties doesn't mean, one, that you need to break them out into these vertex-based properties. You can embed them as properties on a vertex. All right, we'll see what that looks like. Actually, that's where we're headed next. So we're going to take a look at our recommendation engine. And this is using the Azure Data Explorer interface. Unfortunately, this one doesn't have a full screen option. So let's switch over to that. Do we have any questions so far?
No, nothing, just a few comments, but nothing, no real questions.
Okay. All right, so we're going to go to our recommendation engine. You can see this is Gremlin API. I'll expand that just so you can see what we're looking at. So I have my graph. It's this pizza recommendation. I'm going to go ahead and close this so that we have room to work with it. All right. I'm going to let me see. Oh, I'm in the graph full screen. One moment. On a smaller screen, it's a little harder to tell where we're at. All right, so with this graph, let me expand this so you can see. If I go into our pizza recommendations, I'm going to expand that, and then I'm going to select graph. And that will open our graph tab here. G.V, this is the basic. I'm going to get rid of our navigation at this point. G.V is going to get all the vertexes. So think of G similar to like graph. It's everything. .V is for vertex. .E is for edge. Those are key. If I do that, I'm going to scroll down. So you'll see here are results for all the vertexes. There's a graph section, and then this is details for the particular node that's selected. So if I were to select Mark, for example, then you will notice that this changes. We have some properties. So I have a label. I have the name Mark. I have a customer ID. Again, in case I have two customers with the same name, I have some kind of differentiator for my own sanity's sake. But then if we scroll down to something like Pineapple Pizza, we included the description. And this is just to show you that you can have multiple properties tied to a vertex. Bring in the data that you really need. Technically, do we really need the description for this? No, but I wanted to show you that that worked. Now, let's show the graph. Because this is probably my favorite part of working with the Gremlin API in the Data Explorer is this visualization. So I have Pineapple Pizza selected. That's why it's focused on here. Let's talk about the relationships. If I scroll this, can you still see Pineapple Pizza and Sarah?
Yep.
Okay. So Pineapple Pizza and Sarah are considered vertexes. This arrow between them, that's their relationship, that's their edge. This is where we talk about how they were directional. And so when you're thinking about modeling your data, you need to think about the relationships and who owns the relationship. So I bought Pineapple Pizza. Now, how do I know that I bought it? If I select Sarah, and if I expand the properties here on the right-hand side, I'll scroll down. So here's Sarah. That's the node I'm on. If I scroll down, you're going to see targets. So I am the source, and I am targeting Pineapple Pizza. My edge label is bought. So you can read this as Sarah bought Pineapple Pizza. Makes sense so far?
Yep.
Okay. Now let's suppose that you want to see what other pizzas did I buy? Or better yet, let's see what other pizzas people who bought Pineapple Pizza bought. That gets a little trickier because now you need to write the query to kind of trace your steps. So Pineapple Pizza is where we want to start. So I'm going to say, find us. There we go. I remembered from earlier. So we want to find all of the vertices that have the name Pineapple Pizza. There's only one of those. Then we want to find all of the edges that are pointing at it, so that are coming into it, that are labeled bought. Who bought the Pineapple Pizza? Out V, that gets you the vertex. That gets you the who's buying the Pineapple Pizza. But what else did they buy? So we're going to go out all of the edges coming from that person, see what they bought. Now we want to go get the vertices for those, and we want to see the ones that are labeled as item. If I do execute gremlin query, we should have in our results 3. There should be, we'll go into our JSON. Maybe it won't go into our JSON. It's hard on a 13-inch monitor.
Yeah, sorry. I wish our graph portal was better.
That's okay. All right,
not awesome for small screens.
Yeah. It's okay. We work with what we got. So if we go back to our results, there's cheese pizza, there's pineapple pizza, there's you name it pizza. There's no apple pizza. These are the 3 pizzas that I've purchased. So
you've already offended all of our viewers with pineapple pizza. So just straight up apple pizza.
There is straight up apple.
Those aren't good Midwestern appetite values right there, I'm telling you.
Apple pizza is usually marketed as dessert pizza, thinking like the ones at Pizza Hut or Papa John's.
That's some kind of flaky left coast pizza you got going on there. I don't know what that is. No.
I'm in the Midwest.
Beef and corn pizza. It's more of a
see, I'm usually more of a pepperoni pizza. The pineapple pizza was just to see where we stand on that. So and then you name it pizza.
Standing on the sidelines is where I
stand on the sidelines. And you name it pizza. It's got beans, greens, potatoes, tomatoes.
Oh my
There's
God.
a lot.
That's like you buy that's at Trader Joe's or something? Is that where that thing comes from?
No, there's a meme for that. Actually, it's called the You Name It Challenge. My kids taught me that one, so I was like, okay, fine. I'm going to create a pizza specifically for that. So
I get a question from a user here. So is there a way to limit users to edges? That is, your graph maybe includes Sarah bought a pineapple pizza and John ordered more pineapple for the store. I don't know if I understand that.
So
follow up, meaning user and admin data in the same graph.
Ooh,
I don't think that sounds appropriate, or how I would use. Basically, sounds like pizzas you've sold versus ingredients you've bought, maybe to make the pizza.
Yeah, that sounds like something that would be a separate graph, perhaps. Yeah. I wouldn't be mixing the relationships of the supplies and how much we're using and who's using it versus because we're looking at different relationships. I would say those would be done as 2 separate graphs. Mixing admin data and regular user data, that doesn't sound like a good idea.
It doesn't sound right to me either. Like I would expect it to be purpose built, if you will, right? Like you were literally materializing relationships within the graph itself.
Mm-hmm.
Supply for a thing or ingredients that go into a thing and selling of the thing does not sound like I could model that in a way that makes anything's possible. That doesn't feel right to me. So
no, that just from a developing standpoint, keeping my admin stuff separate from my regular user stuff makes a world of difference. And then being able then to set security on the individual objects is a different
I think he
story.
gets it, but it's a maybe bad use case.
Yeah.
but I think you understand what Sarah's saying here is these should be purpose designed.
Purposely, yeah. You need to think through, how is it going to be used?
Yeah.
And then the last thing I'll show with the graph data is the execution profile. And execute gremlin, and then we'll pull the JSON up for that. And you'll see here, then you can see the gremlin that was called. And then you can see things like the usage, the percent time it took. If you're one who wants to learn more about your performance and what it's doing, you can see here that it's going to call get vertices, and then it's going to call like a query, and it's going to do get edges, and so on and so forth. So it breaks it down to each step and how much the step costs. When you're working with graph data, that's probably helpful to understand it a little bit more, what's going on there. But now you can see another way of using your data. And this all started with a relational database. Actually, let me pull that over so you can see what that looked like. So I'm going to bring over my Visual Studio Code. And this that you're seeing here, so on GitHub, I'm Saduki. I'm Saduki everywhere, Twitter, LinkedIn, GitHub. I've created a repo for Azure Cosmos DB, live TV data modeling. You will see that I have some files in here, data modeling.pdf. That's the slides. That includes all of the links that we've talked about throughout here. This create relational model, this is what I started with. When I created this presentation, I started with a SQL, the relational stuff. Now, the way that I handle these things is I do have a cleanup, because I was always building this incrementally. Then we have our creates, and then our data load. And I do have some row numbers to make it easier for us on the order details. And I do have some random numbers in there for quantities. It's Control B, so you can see I did some randomization as to how many pizzas people are ordering. Keep it interesting. But then here you can see that I did a get all orders with descriptions, just a general SQL query. And then this is here, these 4 JSON paths. So this is what I use to create the document data. And then this is what I use to create the graph data. So not only does this presentation show you the data modeling, but then if you're in a relational sense and you want to take your data into JSON, or you want to take your data into graph data, what could that SQL look like? And this is just an idea. For me, the JSON made it so much easier for me to then copy and paste documents into the Data Explorer. Now, is that normally the way you would want to load it? Probably not. You probably want to use like bulk executor in order to load it, but it worked for doing a demo with a few. And then same thing for calling my gremlin. I use my gremlin plus some SQL to generate the queries for me, and then ran them in the Data Explorer. So you will have access to these if you go to the GitHub repo.
Yeah, I put your repo. I just put GitHub Saduki up on the screen there. So I'm guessing people can find your pizza store.
They can find my pizza store
repo in there and look at all the source code for how you set that up.
Exactly.
Yeah.
Exactly. So
I noticed you used just integers in there for your order IDs or whatever like that. I just what's your thoughts about using auto increment numbers because that's something I like. It's something that's challenging. There's no auto increment in Cosmos, right?
Right.
It's the challenge is it's a distributed data store where you maintain a quorum over a set of replicas, and having it's tricky doing something like an auto increment when you have 4 different databases basically all at once.
Right. I would say if you're doing an auto increment, keep that on the relational side, and then have some kind of, if you need to go, like for this example, if we wanted to go from SQL where we keep track of the relational stuff, and maybe we need to keep track of some of that order details for pulling reports later on how the products are getting used, we could store all of that stuff and then have like Azure Data Factory, pull data from SQL Azure, put it into Cosmos, and work with it that way. So I would say if you're doing the auto increment, leave that to the relational. If you need to use that in the case of the order line numbers, those line numbers should be integers. I don't think we would want to see GUIDs for regular people looking at their order history.
Yeah. It's,
But
I mean, you can, right, with something where you can own the entire scope of the thing, like in an order sense, you could do auto increment on the order details if it's all handled within the context of a transaction, or if it's the same document.
exactly.
That's fine. Other users I've seen that needed auto increment in a more broader sense, what I've in the past I've told them is the only way to really implement that in a correct way is to do a distributed lock,
Mhm.
which is a bit of a pain in the butt if you're not familiar with how to do them. Or there's newer things now that can help with that. Like we've got a new increment function on partial documents,
Mhm.
partial document updates, and there's an increment patch operation, which is a possibility. I think I haven't tried it for that, but it will do an increment, and it
Oh,
will avoid. It's specifically designed. Well, let's just say if you're patching different documents, you avoid the round trip of having to go and do a get if it's changed. But on the same one, you may end up with another issue. Anyway, I don't want to belabor it too much. Another question from a viewer here, and I think you touched on this. Would it be nice to have a hotkey to execute queries like F8?
it would be nice. Now, for me, what I usually do is I usually use Hassan's plugin, and so when I'm in Visual Studio Code, then I can actually highlight these things and press F5 and run them. Prior to coming on the show, when I was doing the tech check, I pressed F5 to run the queries and forgot that I was in the browser. So using F5, using a hotkey would be nice if we could use it in the browser. It's harder with browser stuff, though.
Yeah.
Yeah.
I put the VS. That's Hassan's extension. I think
Yeah.
his SQL API, his VS Code extension. So, yeah, folks, if you want to check that out, that's a cool little free tool you can check out, and gives you lots of good little details. I mean, the stuff you kind of want to know, like, am I
Mhm.
hitting indexes? Are you charged? All that stuff. So,
Yeah, it's really nicely done. My only complaint is I wish it worked with Azure Data Studio as well. But Data Studio and Visual Studio Code are out of sync on versions right now, and so doesn't work there just yet.
yeah.
Yeah, if I could keep all of my data tools in one program, that would be glorious.
Yeah,
But
for
alas,
years we had people saying, "Why do you have to be different, Cosmos? Why can't I just use ADS?" We're yeah,
yeah,
we're, we'll get there.
we'll get
So
there eventually. For now, having just that Visual Studio Code interface in both of those, I'm like, that's fine. But yeah, that way I can do my relational and I can do my documents and I can do my graphs without having to go back to the portal.
yeah, I don't even use the portal for anything. I literally just fire up Visual Studio and I just start writing code.
Hmm.
Um, but that's me.
Yep.
Not everybody wants to drop into an editor and write code to get some data out of their database or just to check something. But
It's
yeah,
usually easier than doing the UI.
yeah, yeah.
So, but yeah. So these are the links that are throughout the slides. I put them all into one slide. That way you can go straight to the end and go, okay, that's where we put all those links.
So let me show. There's and people can take maybe screen caps of these things because the pretty PowerPoint formatted versions, nobody can click on those. So I'll just show.
Yeah. Well,
So if you want to,
in
there's
the
some.
PDF in the GitHub repository, they're all clickable links.
Okay. There you go. So you've got it in your GitHub repo. So let me put that back up here. And then people can find the repo for today's episode
Hmm.
and can go and click on all of these in there
Yep.
and can see it in action.
Yeah.
So this is very cool. Very cool.
Yeah.
What's this? Another question. 32 hops between vertices. Is that on the roadmap for recursive traversals? I don't know, Gregor. The answer to your question. I am not that close to our Gremlin database API. You can try just asking the question on our Microsoft Q&A site if you want. I think there's people there that we can get that in front of the right people there, and hopefully we can get you the answer you want. So if you could just ask us the question. You could also ask us on Twitter. I'm usually lurking on Twitter, as Sarah will undoubtedly confirm. So,
Well, and that Azure Cosmos DB Twitter account is very much engaged with the rest of the community. I see the tweets come in. I see the retweets come in. It's a
we're
beautiful
there.
thing.
I'm engaged. I want to help people. That's why that's what I do, is I just try to help make people as happy as possible using Cosmos, especially if they're new. Because, like you said, the more years you've spent doing relational databases, the more frustrated you're probably going to be.
Exactly.
using our database for the very first time. So, but it's a, like I said, this database, you can do stuff that you cannot do otherwise, or is designed to do things in a different way and work at different scale, if you will, than say relational database. So give it a try, right?
Yeah.
So okay, is that it for everything this week?
Yep.
Very cool. Yes, give us your Twitter handle there and your LinkedIn. Very cool. You're very active on Twitter, which is good to see. I'm guessing you're active on LinkedIn too. I'm on there. I'm mostly just looking to see what new job somebody took last week. Like, oh, you quit? Really? All right. There's another one. A great resignation. Now you're working for someone else.
Where did you go today?
Yeah, 20 years at wherever, and then you left. Now you're working at a, I don't know, startup of some sort. So yeah.
Yep. Hey, Mark, you guys have a conference coming up, don't you?
We do. Azure Cosmos DB Conf, April 19th and 20th. I'll put up our little banner there. So yeah, boy, what are we, 12 days away? 3-hour live streams plus almost 20 on-demand sessions. And the live streams 3 live streams across the globe. We'll have an America's time or America's stream, and then 8 hours or so later, we'll do an APAC one, and then we'll do an EMEA one. That'll be on the 20th by that time, and then a whole slew of on-demand sessions. Lots of great sessions with customers, just talking about how they're using Cosmos. Other great content in there as well. Come check it out, April 19th and 20th. You can come see our new sizzle reel, actually. Check out all the sizzle on there. Other stuff we're working on as well, or that we've got that you should check out, is our user group. We just had a meetup last week, I guess, with Lenny LaBelle, and he's done a few of them since we launched the group last summer. We've got another one coming up. I don't think it's this month. We're getting one scheduled right now with Alex Mang. He's a Azure MVP out of Romania and a big friend to Cosmos. He's been doing a lot of the Learn Live sessions for our new certification, which has been fantastic. We did one yesterday. In fact, I was a moderator on one that talked about configuring and using change feed with another MVP, Marilag. And she's been on a number of these as well. So yeah, we've got a new Cosmos DB certification, folks. If you ever wanted to get certified, now's the time to do it. We just got our new exam out of beta, now fully GA. Come check it out. Come take the exam. Come get your specialization, your certification specialization. I don't even know what they call it. Azure Cosmos DB specialization certification. Just rolls right off the tongue. Anyway, so that's Cosmos DB user group. Come check that out. Come check out Cosmos Conf. We've got lots of other episodes as well. This was episode 43. So we've got 42 other episodes, which are almost as good as this one. So go check them out. And we'll have new episodes coming up. We're taking a little bit of a break right now just because we're in a kind of a quiet period before build, when things are getting a little crazy right now as we're preparing for build conference coming up in about 6 weeks, a little more than that, I guess. So anyway, coming out between now and then, we'll have a few more episodes. We've got Cosmos Conf coming up, late part of April, and then build after that. And yeah, that's it. So thank you, Sarah, for joining us this week and talking about modeling both SQL, our SQL API, but also our graph and Gremlin. I think this is the very first episode where we've talked about Gremlin. So
oh, cool. Well,
do
thank
some
you for
more of that.
having me. This is fun.
Yeah, thank you so much. And thank you, everyone, for joining us this week. I don't have anything programmed for next week, but we are working on some additional episodes coming. But like I said, we've got lots of great stuff in the past that we've run. So feel free to check that out. And then don't miss Cosmos DB Conf coming up April 19th and 20th. So Sarah, thank you again very much for joining us this week. And thank you, everyone, for joining us. We'll see you all next time.
Thank you.
Thank you. Bye-bye.